Find the inverse function of f of x equals 8 to the 8x. And so, first of all, let's write the two-variable form for the equation of the given function f of x. It would be y equals 8 to the 8x. And so if we want to go and solve for x, we can do so by changing to logarithmic form, or using the vocabulary of the section we're currently studying, applying the log base 8, or even the common log, to both sides. I suggested the log base 8, so let's do that. Log base 8 of y is log base 8 of 8 to the 8x. So the right-hand side comes out to be 8x using the exponential rule. And so we have the log base 8 of y equals 8x, or x equals 1/8 times the log base 8 of y, which I'll write using the change of base formula as 1/8 times log y divided by log 8. And so the two-variable equation for the inverse is going to be y equals 1/8 log y divided by log 8. This time I did common logs on the top and the bottom. I could have done natural logs. So f inverse of, and I'm sorry, I need to fix that last y that I've got, where I've got log y. I needed to replace the y with an x. And so f inverse of x is equal to 1/8 log x over log 8, or log x divided by 8 log 8. In the next example, we also have an exponential function. We have f of x equals 3 to the x plus 4. And so the two-variable equation is y equals 3 to the x plus 4. Let's take the common log of both sides now. So the common log of y equals the common log of 3 to the x plus 4, and the exponential rule for logs, or the exponent rule for logs, says that we can bring the exponent x plus 4 down times log of 3. Now we distribute the log 3 to get x log 3 plus 4 log 3. We only have one term that has an x in it. Let's leave that on the right-hand side and move the 4 log 3 to the left. So we'll have log y minus 4 log of 3 equals x log 3. Now by division, we'll have x equals the difference of log y and 4 log 3, all divided by log 3. So the two-variable equation for f inverse would be y equals log x minus 4 log 3 all over log 3. And this expression is also equal to f inverse of x. So let's go to the next example. This is the log example. Find the inverse of f of x equals log base 4 of x minus 2. So our two-variable equation for f is y equals log base 4 of x minus 2. I'm going to then exponentiate both sides using a base of 4 since we have log base 4. So we get 4 to the y equals 4 to the log base 4 of x minus 2. And since we're exponentiating a log with the same base, we are left with the argument on the right-hand side, which is x minus 2. So x would equal 4y plus 2. F inverse would have a two-variable equation, y equals 4 to the x plus 2. And so f inverse of x is 4 to the x plus 2. We have one more equation, also a log equation. And so this one is f of x equals log of 8x. So f has the two-variable equation y equals log, common log, of 8x. We can exponentiate base 10. Since we've got a common log, we get 10 to the y equals 10 to the common log of 8x, which gives 10 to the y equals 8x, or x equals 1/8 times 10 to the y power, or 10 to the y divided by 8. So f inverse will have the equation y equals 1/8 times 10 to the x. And this is also what is called f inverse of x. Now, I'd just like to look at this example again and notice that for the function f, we start with x, we multiply it by 8 to get 8x, and then we take the common log. So times 8, and then take the log. For f inverse, we start with x, and we do the inverse of these operations in the reverse order. So where there was a log, there will be an exponentiation base 10. So our first step will be 10 to the x. And where there was a times 8, there'll be a divide by 8. And so, or multiply by 1/8. So we'll get 1/8 times 10 to the x. This approach works as long as there's only a single term involving the variable x in the original function. Let's look at the third example in the same light. Notice that with the function f, first of all, we subtract 2 to get x minus 2, and then we take the log base 4. So f inverse the inverse of the operations in the reverse order. So the last process in f was log base 4. Its inverse would be 4 to the power. And then when we subtracted 2, we would add 2. This is the essence of the inverse functions, that they reverse the order of what was done and replace what was done in each step with the inverse. In the one that said f of x equals 3 to the x plus 4, or function f takes x to x plus 4 and then exponentiates base 3. So this would be then 3 to the x plus 4. So the inverse function starts out by doing the inverse of exponentiation base 3, which would be log base 3. So we'd start out with log base 3 of x, and then instead of adding 4, we would subtract 4, and we'd get log 3 of x subtract 4. Now that doesn't appear to be the same as what we had below, but if we use the change of base formula, we would get log base 3 of x. I'm sorry, that is wrong. We would get log x, that's a common log of x, divided by the common log of 3 of 3. Minus 4. And then if we multiplied by log, common log of 3, top and bottom, we would get a common denominator of log 3. And that will be equivalent to the answer that we got for f inverse. In the first example, we have y, or f takes x to 8x, and then exponentiates that base 8. So multiply by 8, and then exponentiate base 8. So f inverse would start with x, take log base 8, which would give us log base 8 of x, and divide by 8, or multiply by 1/8. And so we'd get 1/8 log base 8 of x. which when we